This is Daryl with Cisco Hands-On Training. It's the 21st of March 2009, and today we're going to talk about HSRP, which is the Hot Standby Routing Protocol. Again, the website is on CiscoHandsOnTraining.com, and in iTunes you just search on Cisco Podcasts to find the most popular Cisco podcasts, and we're right up there in the top batch. I want to thank Robert Walter again for the 2621 that he loaned me, and we're going to be using that for the first time today in class. Today we're talking about HSRP. It's the Hot Standby Routing Protocol. It's like most other protocols, it's a protocol which solves a problem. What is the problem we're trying to solve? Here's a network where we have two switches and we have two redundant routers which are exits out to the rest of our network. And the router on the left has an IP address of 10.1.1.2, and the router on the right has an IP address of 10.1.1.3. Now on our switches and on any hosts connected to the switches, we want to set a default route. And we want that default route to work no matter even if one of these two routers goes down. So if we set our default route to be 10.1.1.2, then if the router on the left goes down, then we're inoperative. And if we set our default route to be 10.1.1.3, then if the router on the right goes down, then again we're down. So to fix this and enable us to have a redundant outbound router, what we want to have a virtual IP address, 10.1.1.1, which is somehow shared between these two routers, the one on the left and the one on the right. And that way, if either router is up, then we're able to connect out to the outside world. The first protocol to enable that in Cisco iOS was the HSRP protocol, Hot Standby Routing Protocol. It's a Cisco proprietary protocol, and the way it works is the two routers talk to each other over a multicast address on the net, and they elect a router to be the active router. And that active router will respond to ARP requests for 10.1.1.1. If that active router goes down, then the backup router will detect that and take over active. So let's look at how we configure it. Here we are on the left router. Show run int eth0. And you can see we have our IP address 10.1.1.2. And on our router on the right, show run int fast0/0. And again, our IP address is 10.1.1.3. Let's go ahead and configure the Hot Standby Routing Protocol on the left router. Conf t int eth0 standby IP 10.1.1.1. That's it on the left router. And let's go ahead and look at the right router. Conf t int fast0/0 standby IP 10.1.1.1. So now on the left router, show standby. Ethernet 0, group 0. Standby is a concept of groups. So each group, well, we'll talk about that in a bit. And we went from standby to active. So when I'm doing show standby, it's showing the information about the Hot Standby Routing Protocol. And you can see our state is active. The virtual IP address is 10.1.1.1. There's a virtual MAC address. So this virtual MAC address is 00000C07AC00, and any ARP requests from other hosts for 10.1.1.1 will result in this MAC address being responded to. Let's look at show int eth0. And I'm looking for the MAC address. And actually the MAC address for Ethernet 0 is 00000C07AC00. That's interesting. That the MAC address, the virtual MAC address, is the same as the MAC address on the router, but, well, we'll take a look at that. So show standby. Hello time is 3 seconds, so every 3 seconds we're multicasting out a hello hot standby routing protocol packet out to a multicast address. Any other HSRP speaking routers on the net will listen for them. The hold time's 10 seconds. So if you do not see let's say you're the backup router, and if you, in fact, let's go ahead and look at the backup router, show standby. The state is standby on this router, and we're sending hellos every 3 seconds, because the hello time is 3 seconds. The hold time is 10 seconds. So if we do not see a hello from the other router in 10 seconds, then we will believe that they are down, and then we will begin the process to become active. Preemption is disabled. Preemption is hot standby routing protocols have a priority, and here you can see the priority is 100, which is the default, and on the other router the priority is 100, which is the default. And if with preemption disabled, no matter what the priority is, if you are already active, you will stay active. But if preemption is enabled, then if you have a higher priority but you're the standby router, then you will assert that you want to become primary and you will take over active. Let's go ahead and look at this from the standpoint of one of the switches below. Show run int vlan 1. So this switch has an IP address on that same net. Conf t IP default gateway 10.1.1.1. So I set my default route to be the virtual IP address. Let's see if I can ping 10.1.1.1. I can ping 10.1.1.1. Show ARP. The ARP entry for 10.1.1.1 is the virtual MAC address. Ping 10.1.1.2. Show ARP. So not quite what I expected, but the MAC address of the real router is this MAC address, and it's the same as the MAC address of the HSRP. Now let's go ahead and try to make the router on the right be primary. So conf t int fast 0/0 standby priority 110. Show standby. So you can see now my priority is higher, but preemption is disabled, and so I'm still in standby mode. And I will not take over the active even though my priority is higher. Let's go conf t int fast 0/0 standby. Let's look at the other commands out here. You can see there's about 10 commands for standby, which is not too bad. Standby preempt. Show standby. And now you can see we logged the message. We changed from standby to active because we enabled preempt. And when we enabled preempt, it realized that our priority was 110. Show int fast 0/0. Looking for the MAC address here. Here's the MAC address up here, 0003, but we're still using the virtual MAC address 00C07AC00. So it's, in effect, we're remembering the old, the MAC, whatever. So the MAC address, from the standpoint of the clients on the net, the MAC address of 10.1.1.1 has not changed. But now 10.1.1.2 is back to a different MAC address. Ping 10.1.1.3. Show ARP. Yeah, this is what I expect. So the MAC address of 10.1.1.3 is the burned in MAC address of the router on the right. The MAC address of 10.1.1.2 is the burned-in MAC address of the router on the left, and the MAC address of 10.1.1.1, which is a virtual IP, is a virtual MAC address, which is configured based on the standby. Okay. So that's standby priority and standby preempt. The default priority is 100. The highest priority wins. But if somebody else is already, if another router is already active, then you only become active if the other router goes down or if you have preemption enabled. Let's look at our notes. Oh, interface tracking. Okay, so to unify our config, conf t int eth0 standby preempt. So, and actually on the router on the right, let's make conf t int fast0/0 standby priority 105. And we'll configure a loopback int loopback 0 IP address 10.1.2.5 255.255.255.0 int fast0/ make sure our loopback is up int fast0/0 standby track loopback 0. Show run int fast0/0. So now what we're doing is we're using a new feature here. Our standby priority is 105, which is still higher than the other side, which has the default of 100. Standby preempt is enabled on both sides. But what we're doing is we're tracking the loopback. And what I'm doing here is I'm simulating tracking an uplink. Let's say these are WAN routers at a remote WAN site, and you got one uplink on this router and one WAN uplink on this router. Well, you can track those physical interfaces in HSRP priority, and if the interface goes down, then you decrement your priority. So you set your priorities to be 5 higher on your primary WAN link, on the router with the primary WAN link, and then you track the WAN link. If the WAN link goes down, it decrements its priority, and then the other router will take over. So, int loopback 0 shut. So you can see what happened here. When I shut loopback 0, then HSRP for fast Ethernet 0/0, it decreased its priority, and because the priority decreased below the other router's priority, and the other router had preempt enabled, which is important, then we actually went to a speak mode or a standby mode. Show standby. So fast Ethernet 0/0 state of standby, and priority is 95, but it's configured at 105. We're tracking one object, and there's, of the objects that we're tracking, 0 are up. Now by the object it means loopback 0, and the decrement amount for this tracking is 10, which is the default. Conf t int fast 0/0 standby track loopback 0, and now I can configure a priority decrement. I could right now the default priority decrement is 3. The default priority decrement is 10. I could change it to something else. Now int loopback 0 no shut. So loopback 0 became active. Our priority tracking our standby priority tracking realized that the loopback 0 was up, so it no longer decremented the priority by 10. We went back to 105, which is higher than the 100, which is the default on the other side. And then because we had preemption enabled and our priority ended up being higher, we actually went back into active mode in HSRP. What else do we want to talk about? So that's standby, priority default is 100, Tracking, by default, you lose 10 when you're tracking. We preempt. We configured preemption, so only when default is preemption is off. If you preemption is on, then if your priority somehow becomes higher than the other side, then you will take over the active role. Secondary IP. Let's say we have multiple IP addresses on one subnet. Conf t int eth0 standby 10.1.1.17 standby IP 10.1.1.17 secondary, and on the right router conf t int fast0/0 standby IP 10.1.1.17 secondary. Show run int fast0/0. So you can see our configuration here. We actually have two IP addresses configured, and they're in the same subnet, and one of them is a secondary IP. What does that do? Well, ping 10.1.1.17. It's pingable. Show ARP. And you can see in the ARP table, it's configured with the same. In the ARP table, it's configured with the same MAC address pointing at the two different IPs. So now we have two virtual IP addresses. Now let's say that we want to do something fancy. Let's say we have two WAN links and we want a load balance between them. So in that case, what we could do is we could have two subnets on this net. Well, we could have two default IP addresses. Say we want to have .2 be the default gateway, or .1 be the default gateway for the one WAN uplink, and .17 to be a default gateway for the other WAN uplink. Well, and then we can have half of our hosts configure to set their default route to be .2 or .1, and half of their hosts could set their default route to be .17, and that way we tend to get better load balancing on our WAN links. Now, I'm not advocating you make this configuration change, but let's say we wanted to do this. Okay, so show standby. Oh, that's on the switch. Show standby on the router. Show standby. And so you can see right now the router on the right is active, and it is active for both 10.1.1.1 and 10.1.1.17. And the problem is that this is one standby group. The standby group is either active or passive, and every IP address associated with the standby group is active or passive. What we need to do this is two separate standby groups. So let's do that. Conf t int fast0/0 no standby IP 10.1.1.17 secondary, and on the other router no standby IP 10.1.1.17 secondary. Now let's create a new standby group. Conf t int ethernet 0 standby, and then I hit question mark, and it actually has a group number. Before, I did not configure in all the previous standby commands that I've done so far, I did not configure a group number, and the default group was, wait for it, group 0. Now let's create a different standby group. Let's call it standby group 1. Standby 1 IP 10.1.1.17. Ooh, this particular router here cannot support multiple HSRP standby groups. Well, let's see if the 2600 can handle that. Conf t int fast 0/0 standby 1 IP 10.1.1.17. Okay, so I cannot fully configure this because this router on the left of it is 2500 and it just doesn't have the ability to handle enough MAC addresses to do multiple standby groups in its Ethernet hardware. So that's probably why that MAC address was acting weird earlier. If you remember when it was the same MAC address on the standby group and on the burned-in address on the right, whereas on the burned-in address, whereas on the right it was a different MAC address for the standby group and the burned-in Ethernet adapter. So yeah, the 2500 is an much older router with fewer features. Okay, but we're going to simulate this. We're going to configure the router on the right, standby 1 IP 105, priority 105, standby 1 priority 105, standby 1 preempt, and then for standby group 0, priority 105 on the left, and then on the router on the right, standby group 0, priority 100. Okay, that was confusing. Let's go back and look. Show run int fast 0/0. Okay, so the router on the right, we have two standby groups. The standby without the number is group 0, and that one has an IP address of 10.1.1.1, and its priority is 100 on the right and 105 on the left. We've enabled preemption on both routers, and we're tracking the loopback. We're not. And then the second standby group, we set the priority as standby group 1, IP address 10.1.1.17. The group 1 is a priority higher on the right, preemption's enabled, and standby 1 track loopback 0. So let's go ahead and look at the router, ping 10.1.1.1, ping 10.1.1.17, ping 10.1.1.2, ping 10.1.1.3, show standby, show ARP. So this router has 10.1.1.1 is the primary is the router on the left, and the router on the left is the 2500, which can only support one MAC address, which is why we have the same MAC address for HSRP as the other one, as the burned in. And then 10.1.1.17, the priority is the router on the right, which is and you can see the MAC address is incremented 1 here. This is the MAC address of HSRP group 0, and then you add 1 for every group number. So this is the MAC address for HSRP group 1. And actually what turned out to have happened here is when 10.1.1.2, when the router on the left, which is the old 2500, is HSRP primary, it looks like the hardware can only support 1 MAC address. And it can change that MAC address, but it can only support or respond to 1 MAC address at the time. So what it does is it understands that the standby IP is the most important MAC address, because that's generally the MAC address that you're actually using for traffic. So it actually sets that standby MAC address to be what it's supposed to be, and then it just changes the burned-in MAC address to be the same, just because it can only support 1 MAC address at the time. So I learned something new today too, so that's cool. Let's look at the show standby command. It would help if I looked at the show standby on the router. So you can see I have 2 groups, and at Fast Ethernet 0/0, group 0, my state is standby, and in Fast Ethernet 0/0, group 1, my state is active. let's see a failover. So I'm on the left router, Ethernet 0, shut. So we're going to simulate a failure here. Look at the right router. 5, 6, 7, 8, 9, 10. About 10 seconds after I shut down the interface, the group 0 became active on the right. And again, that's in group 0. The hold time is 10 seconds. So we've got when we shut down the link on the other side, it was about 10 seconds before the router on the right realized that, hey, the previously active HSRP router is no longer operative, so I should take over. T NTTH0 no shut. So I did the no shut, and almost immediately the router on the right for group 0 becomes standby. Okay, let's say conf T NTTH0 Let me show you a little war story. Let's say NTTH0, talk about an outage that occurred. Let's say that this router is just in storage somewhere, and it used to be in production. And when it was in production, it had IP address 192.168.3.2, 255.255.255.0, standby IP 192.168.3.1, standby priority 200, standby preempt. So this is just an old router. And then this router on the right. Let's say that the router on the right is the active for this net. Conf T int fast 0/0, standby priority. Oh, I was supposed to shut down the interface. Int conf T int ETH shut. Do show run int fast 0/0, int fast 0/0. I'm already there. Standby priority. Okay, so let's say this is a desktop network in a campus building or something like that. And the router on the right is HSRP active for the floor, and some guy gets a router and just plugs it into the net. And you have no idea what the config is. The IP address is not even on the same net. He thinks it's going to be harmless because it's not connected to anything else, and he plugs it in. So let's, here on the switch, ping 10.1.1.1. I can ping 10.1.1.1, conf T, NTTH0, no shut. The guy plugs it in. And what's happened, now let me ping 10.1.1.1. I can't ping it anymore. Everybody in the floor of this building, their network just stopped working because somebody came and plugged the router with a random old configuration with the default standby group into the net. Let's look at the show standby. So a P1 gets generated because everybody on the floor lost network. You get paged, you dial in, you log into the router there. The router looks operational. You see this log message talking about actually this log message is very helpful. It says that fast Ethernet 0/0 group 0, the active router's virtual address is different from the locally configured address. So at least there's a log message on the router. You log into the router, you do a show log. Well, if I had the logging configured right, and show standby, at least that's a console log. And you can see for standby group 0, I'm in state standby, but I can actually see the IP address of the active router, and I can see that the IP address of the active router is something different, completely off the net, and something's wrong. So then what I should do is I should look at the MAC address of that router, and then I need to go through my switches in the net and try to disable the router. So even though the net is down, I can't get to, even though I can't, like here's a switch, even though I can't get to the switch from off net, at least from this router here, telnet 10.1.1.1, nope, that's not going to work. Telnet 10.1.1.2. Actually, if I went back and looked at my documentation, I would see that the switch involved in the outage is 10.1.1.4. So I know the MAC address of my bad guy. Here's the MAC address of my bad guy. Telnet 10.1.1.4. Show MAC address table. And you can see here's the MAC address of the bad guy. It's out fast Ethernet 0/1. And if I had a enable password configured on this switch, I could enable right now and shut down that port. In fact, conft enable. Just configured an enable secret password, enable Cisco, conft int fast 0/1, shut. And here on, so I shut down, so on this switch, I identified the MAC address, the port that was going to the MAC address. Well, on this router, I knew from the show standby what the MAC address was of the bad router, of the bad guy. And I knew he was configured completely wrong because he had a 192 net address, or a 192.168 address. I looked up his MAC address, then I looked at the MAC address tables, not the ARP tables, but the MAC address tables on these switches. On switch 1, I saw the MAC address with an out fast Ethernet 0/1, which I knew was an access port. So then I shut down that port, and as soon as I shut down the port, then from switch 1, the network is back up again. As soon as I shut down the port on this guy, then the bogus HSRP advertisements from this router are not getting onto my net anymore, and this guy assumes active again. Okay, so that's a example of a HSRP outage. You're just sitting there, and then some guy comes and plugs a router in with an old HSRP config into your net, and it wins the priority election, and because it's completely misconfigured, I mean, it's not configured for your net, it can still win the election even though it has a completely different IP address, and then your net is down. And the way to fight that is you log into your router, you do the show standby, you find the MAC address of the bad guy, you log into the switches and find the MAC address of the bad guy, and you shut down the port. Another way to do it would be just to increase the priority. If I saw that the standby priority was 200, then on this guy, at least I could set the priority to be even higher, like priority 230. That helps for accidental interruptions like that. Doesn't protect you against intentional ones. Okay, what else do we want to talk about? We did secondary IPs, we did standby groups. I showed you a conflicting group where an old config was messed up. Now, HSRP is a Cisco proprietary protocol. There are vendor-independent protocols, VRRP. So if you're trying to set up this kind of redundancy between non-Cisco routers, or between a Cisco router and a non-Cisco router, you need to use something that's vendor-independent as opposed to vendor-proprietary. VRRP is very similar to HSRP, and you can see it's just, instead of standby IP, it's VRRP and then the group number and then the IP address. So it's very similar configuration. GLBP is a little bit more advanced. One of the problems we had here is that the router on the left could be primary, or the router on the right could be primary. GLBP has the ability, is the gateway load balancing protocol. It serves the same function, except it has the ability to respond to some ARP requests for the default router ID with the MAC address. It actually responds with multiple MAC addresses, and it can respond with the MAC address of a router on the left or a MAC address of the router on the right. And it can still fail over, but that way under normal circumstances about half your traffic goes out the left and half the traffic goes out the right. So in that case where we had two WAN circuits going out, GLBP would be a very good way to make sure that some of your traffic goes out on the left side and some of the traffic goes out on the right side. GLBP, you can see it's a similar config, GLBP 1, the group number, the IP address, and get rid of this. And then but then you also need to configure load balancing to actually enable the load balancing. So by default, it won't load balance. You have to configure it. I'm afraid I can't give you an example of VRRP or GLBP because the OS versions on my routers don't support that, and I don't have enough memory to upgrade. So that is it for today. That's HSRP. Again, HSRP is the hot standby router protocol. It's a way when you have a default route on all your hosts on a net, you can have a virtual IP address shared between your two redundant routers, and that way if one router goes down, the other one will take over the load. And there's a more modern GLBP load balancing protocol which allows you to actually do outbound load balancing, where both routers will each try to take up some of the load. Thank you very much.